Topic 3.1 The significance of mechanical properties and testing. If you have a look onto these three pictures, you see three different engineering applications. The first one here is the huge suspension bridge. Down here is the chemical process plant, and on the right is the solar thermal power station. All these three applications require good combination in materials, design, and processing. And for engineer to develop the new product or the new component to do the job like this, they will start with new product development, and that will need design and selection of materials. And then the second step is the materials testing. They have to test the materials to ensure that the materials can do the job that they designed at the first place, and that will comply with standard and compliant tests. And next, with the help of computer-aided engineering, nowadays the engineer don't need to get trial and error anymore, so they can simulate a situation that might happen in the service condition onto the computer and get optimization of the design. And next, here comes the process development, and to see how feasible it is that the materials can be processed to actually get the component. And after forming the metal pieces into desirable shape, and that component will be tested on the full-scale test and also the integrity test to make sure that the component can do the job under service condition in a specific lifetime that it has been designed. For example, if you're buying a car, how long do you expect to use that car? 1 year, 2 years, or 8 to 10 years? If you think about critical parts like a drive shaft that would be under fatigue and torsion, then the engineer have to select the material that perform best under fatigue and torsion. To make sure of that, have to do the standard test and compliant test with the help of computer aiding and run through the process development. After that, testing the full scale that the component can actually do its job under the design time period with appropriate safety factor. And after all the stages have been accomplished, and then it's off for the market. So you see that material testing is very important to make sure that all the components that used in all the applications surrounding us in our daily life are safe for us. And what kind of information would be obtained after doing the mechanical testing? And if you have a look on this picture, so what happened to the piece of metal like this being engraved at both ends and apply the tensile load on the vertical direction like this, or we can say this piece of metal has been uniaxial tensile test. Of course, the metal piece will resist against the load applied at both ends. The more the metal resists the load, the better or the greater strength the metal is. And that's a very simple information that we can get from the test like this. And what else can we get from the test information? From the picture here, you can see that if the materials give a very high strength, and you can guess that the piece of metal might have been processed through mechanical working, because that kind of process will give the material strength. On the other hand, if the strength is low, it might be that that piece of metal might have been cast, because the castings will give coarse microstructure, and that will give low strength. That's the piece of information that we have from the test. So we can know roughly what kind of forming process that the material has been experienced. Moreover, if we investigate the metal itself, we can look through the microstructure of the metal and see whether it's the fine grain, or is the dendrite, or is the coarse grain. What kind of microstructure has been made up of for this piece of metal. And even more, if you know that if this piece of metal may form steel, you can go back what type of crystal structure for this steel. And of course, that is BCC. And that will influence the mechanical properties of this material. Therefore, we have to choose appropriate mechanical testing to tell us the information that need to serve the engineering application that we designed at the first place. The purposes of mechanical testing are to determine critical parameters that can be used for the selection of materials based on design integrity, and to obtain materials parameters by applying mechanical loading irrelevant to those obtained in service condition. Imagine if we talk about suspension bridge, you think about the loading condition first. The steel cable is under tensile loading. Therefore, the mechanical testing most suitable for this suspension bridge is tensile test. And if you think about something else, mechanical gears, it wouldn't be subject to tensile loading, wouldn't it? It might be subject to fatigue or compression. So you have to look for all the kind of tests like hardness test or fatigue test, for example. And therefore, we have to design what kind of test that we have to apply to get the materials parameters that related to the components under service condition, like tensile test, compression, torsion, fatigue, impact, under the standard test methods. And this is very important because if we don't have the standard test, we can't tell the difference. And what's the most important thing is to interpret the test data with care for safety reasons. And if you interpret the data not properly, you may be facing the consequences that you may not like. For example, again, the suspension bridge. If you interpret the test data too optimistic that the steel cable can withstand the load at a very high level, and if you ignore that on the production scale, sometimes defects taking place or imperfection might be in your component. And if you don't include the safety factor before using it, and that suspension might fail to function. And we have seen some cases on the news recently. So all of the mechanical test data need to be interpreted with care for safety. Now let's see what kind of mechanical testing is required for this engineering component. Let's have some guess. This is the mechanical gear teeth. Second one is the connecting valves. Next is the bullet case, turbocharger, air gun suspension bridge, solar thermal power station, piston valves, and nuclear power plant. Can you think of it? They are all subject to different types of forces, right? You might be answering this question after the end of this chapter. First of all, we have to look for the type of force that the component may have been experienced. For example, if the materials or components been experiencing tensile force, and therefore the most suitable test would be unit actual tension test, and the mechanical properties of parameters that might be obtained are tensile strength, yield strength, ductility, for example. And this will follow the standard test method, which is important. This, for example, I'm giving you ASTM E8, and this picture shows the rod type standard specimen used for the tensile test. And next, if you think of mechanical gear, and the surface of the gear must be hard enough not to wear off in service. So in this case, the material would subject to the test under indentation, and the hardness tests that recommend for metallic materials are Brinell, Brockwell, and Vickers, following the ASTM E10 and so on. And for the fatigue, if the material is under cyclic loading in service, can you give me some example of this? The drive shaft that we talked about this earlier, and what else? The wind turbine that keep rotating, or even the machine that vibrating while working. And the test parameters are fatigue strength or endurance limit, and also the fatigue life. It means that how long that they can use that materials or component without failure. That will be following the ASTM E466-15. And for the materials that's subject to tension at high temperature, can you think of anything? For the example that we have before, and that's subject to creep. So we have to prepare the sample subject to loading. At the same time, we have to apply the temperature, and that we do the creep test and giving the creep strength and the creep rate. And finally, the impact test. And normally this kind of test will be carried out for the materials that is subject to brittleness. And if you have a look at all the specimen types, you can see that for the tensile, fatigue, and creep are in common shapes like a dog bone, and then you apply the load for both ends. But for the impact specimen, we have to simulate the notch as the defect on the test piece, and I will give you some more detail about this.